Hello, welcome back to the channel. So let's do a different kind of question, a question which is indirectly based on Riemann sums. And these type of questions are also quite popular in the midterms and final exam. And we'll talk about the most favorable approach in order to solve this question. So in these type of questions, you'll basically get a table which will represent your y and x values. As in this case, your y value is the velocity of the car and the x value is the time taken. And based on these values, based on the values that you'll see on the table, you will be either required to calculate the best possible upper estimate or the best possible lower estimate, and that will be done by using Riemann sums. But before solving this question, let's revise some concepts related to Riemann sum. So popularly we have two different types of Riemann sums. One is the left Riemann sum and the other one is the right Riemann sum. In the left Riemann sum, your height of the first rectangle is equal to the value of the function at the first endpoint. In the right Riemann sum, your height of the last rectangle is equal to the value of the function at the last endpoint, at the right endpoint. And based on these Riemann sums, we either calculate an underestimation of the area under the curve or an overestimation of the area under the curve. And in this case, since my function is increasing, my left Riemann sum would give me an underestimate and the right hand Riemann sum would give me an overestimate to the area under the curve, which you can easily see in this case as well, based on the example that you have on the screen, right? Also, please note that this pattern of underestimation given by the left hand Riemann sum and the overestimation given by the right hand Riemann sum is only applicable when the graph is increasing. If you have a graph which is decreasing, this underestimation and overestimation will swap places. So the left hand Riemann sum when your graph is decreasing will give you an overestimate, and if your graph is decreasing and you're taking the right hand Riemann sum, it will give you an underestimate. And I would highly suggest you to think over it and get a clear idea why this is the opposite case for a decreasing function. You can start with the basic decreasing function, and based on that function you'll clearly see that if you take the left hand Riemann sum in that case it will give you an overestimate, but if you take a right hand Riemann sum in that case it will give you an underestimate, which is completely opposite to the case when your function is increasing. Feel free to comment down in this video if you still didn't get why it's the opposite case in decreasing functions, and I'll reply to your comment as soon as possible. But the main question is, why are we discussing about the underestimation or an overestimation? The reason why we are discussing is because in these type of questions you have to calculate either the best possible upper estimate, which is given by the overestimated area under the curve, or in some cases when you'll have to calculate the best possible lower estimate, you'll take the underestimated area under the curve. So that is why we started with Riemann sums and we talked about underestimation and overestimation given by Riemann sums. So now let's continue with the previous example and see how it relates to the current question. And you'll clearly notice in this case that when I'm taking the underestimated area under the curve, the height of my four rectangles are the y values which are given by my first four x values, right? But in the other case, you'll clearly notice that when I'm calculating the overestimated area under the curve, the height of my four rectangles are given by the y values taken with respect to my last four x values, right? So that is the difference between an underestimated or the best possible lower estimate and the best possible upper estimate given by the left hand Riemann sum and the right hand Riemann sum in this case. And now based on all these observations, it would be very easy to calculate the answer of this question. In this question, we have to calculate the best possible upper estimate for the distance that the car traveled. And since my distance is equal to velocity multiplied by time, I'm basically taking my rectangles and summing them up in order to get the best possible upper estimate or the best possible lower estimate. So now let's solve this question. And we can clearly see that my function is increasing in this case, right? Since my velocity is increasing as my time is increasing. And in this case, since I have to calculate the best possible upper estimate, I know that I'll have to take my right hand Riemann sum in this case, because when my function is increasing, my right hand Riemann sum gives me an overestimate, which would be equal to the best possible upper estimate in this case. So I'll basically take the right hand Riemann sum, which in this case would be calculated by taking the last four velocity values from the table and multiplying it with the time interval. And since the time interval is same in all the cases, I'll take the sum of my last 4 velocity values and multiply it with 0.5 in order to get the best possible upper estimate in this question. This question can also be extended to calculate the best possible lower estimate for the distance traveled, and I'm sure it would be very easy for you to calculate the best possible lower estimate in this case. If you want to calculate the best possible lower estimate in this case, you'll basically take the sum of your first 4 velocity values and multiply it by 0.5, and the final solution would be your best possible lower estimate. So that's it for this video. I hope it made sense why we used this approach in order to calculate the best possible upper estimate. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye.